Good evening and welcome you to the eighth session of Science Talks organized by Science Association, Sir Varsharambhav College, Pune. Today's talk we have organized in collaboration with Department of Electronics, Sir Varsharambhav College, Pune. Today with us we have Professor Dhananjay Dute, Vice Principal, Science, Dr. Professor Sanjeevani Vipat, HOD, Department of Electronics. Then today's eminent speaker, Dr. Jayant Khedkar, former head Department of Electronics, Ferguson College, and my active colleague of Science Association, Professor Prashant Mamni. So I welcome you all, and now I would like to request Professor Dhananjay Dute to say the few words. Please, sir.
Thank you, sir. Today I am happy, very happy, because we will hear eminent Professor Jayant Khedkar, very enthusiastic, all-rounder. All-rounder in the sense, he was former head of Electronic Science Department, Ferguson College. Also, he is very good physicist, mathematician. He also worked in different science subjects. So today we will hear him and we will enjoy his talk. So thanks for him for accepting our invitation. Now I will ask our HOD Sanjeevani Vipat madam to welcome him. Madam.
Hello everybody. Good evening.
Hello.
First of all, I must congratulate Dr. Sandeep Kakade sir for arranging various programs successfully under Science Association, irrespective of the limitations because of Corona pandemic. And also Professor Dute sir for giving the complete support for all these activities. This daily lecture series, Science for All, we are actually enjoying for last few days, and it is very much nice and informative feast for us. Thank you, Kakade sir. Today's lecture is related to electronics. Electronics department was founded in 1986 in SP College. Electronics is such a subject that it has applications in every field. But the developments in this subject are so fast that it is very much difficult to catch. But still, as our college has become autonomous, we are trying to include the latest topics in our syllabus which are suitable for undergraduate course. Our today's distinguished guest is Professor Jayant Khedkar. On behalf of SP College Electronics Department and Science Association, I welcome you, Professor Jayant Khedkar sir. Thank you for accepting our invitation.
Thank you.
Khedkar sir was head of the Electronic Science Department in Ferguson College for 15 years. He is actually a polymath person. He is expert in many subjects. Along with electronics, he is expert in physics, ancient Indian science, mathematics also. He has done a lot of work in making mathematics easy and interesting by or through his lectures and his articles, books, and blog also. He is very much active in social work also. He has many awards also. He is one of the editor of magazine Srishti Dhyan. Do you know the magazine Srishti Dhyan? Srishti means nature and Dhyan means knowledge. I am explaining this for our non-Maharashtrian students. This magazine is founded 93 years back by eminent personalities at that time, Ragnar Paranspe, Dr. Dinkar Karve, etc. Dinkar Karve means, do you know Karve Road? I think there is nobody in Pune who doesn't know Karve Road. The name of Karve Road is after the great personality Bharat Ratna Maharshi Dondo Keshav Karve. Dinkar Karve Dr. Dinkar Karve was his son, and he was great educationist. You may think that this information is a diversion in the current topic, but otherwise, how would we know that such a long heritage we have, and these people have kept this for us? And this heritage is actually continued by the people like Khedkar sir. They are using this. So many such great personalities have worked as editor for this Srishti Gyan. So you must go through that. Now let's come to our topic. The formal introduction of Khedkar sir will be given by our Prashant Mahamuni sir from Electronics Department. So I request Mahamuni sir to continue.
Thank you, madam.
Thank you, madam. It is my great pleasure to introduce Khedkar sir. Being his student, I am very pleased and very happy that I get the opportunity to introduce Professor Khedkar sir. Sir's academic qualification include MSc MPhil in Physics, DHE. Sir retired as a former head from Department of Electronic Science, Ferguson College, Pune in September 2014, and also worked as member of BOS, that is Board of Studies in Electronic Science in Savitribai Phule, Pune University. He has served till 36 years. His awards include Best Research Paper Presentation Award by Indian Physics Association, Best Teacher Award by Indian Association of Physics Teachers. Sir has various publications against his name. These include 23 research papers and various science articles in Srishti Gyan Masik. His research area include ellipsometric study of thin films. Sir has taught various subjects at UG and PG level, which includes nanoelectronics, digital signal processing, quantum mechanics, statistical mechanics, electrodynamics, solid state physics, and mathematical methods in physics. Sir has also published 11 electronics textbooks and 3 mathematics books. Recently, he has published a book on mathematics, that is Maitri Ganitashi, and it is published by Bharatiya Vichar Sadhana Prakashan, Pune. Sir has social work against his name also. He has worked as NSS program officer for 8 years and received certificate of appreciation from Central Minister HRD New Delhi for National Integration Camp. He has also worked for blind men and physically handicapped persons. Sir is also working currently with Vidya Bharati and Srishti Gyan Masik, Pune. Sir's areas of interest include Vedic mathematics and ancient Indian science. He has also started a blog in mathematics with the name professorjvkhedkar.blogspot.in, and this blog is seen by about 80 countries in the world and contains more than 1300 problems in mathematics. During Corona period, he has posted 162 posts in mathematics, and they were published in English for the benefit of school students and teachers under the activity Problem Solving Sessions in Mathematics. He has also started a YouTube channel in Marathi language to aware the students about mathematics, and it is Maitri Ganitashi, started on 22nd July 2020. So I request Professor Khedkar sir to continue his talk.
Yes, thank you, Mahamuni sir.
Sir, thank you, Mahamuni. Thanks for the introduction.
Yes, thank you, Mahamuni sir. Introduction. Respected Principal of SP College, Honorable Vice Principal, and my friend Professor Divte sir, the head of the department, Vipat madam, Professor Mahamuni, then the person behind in the, or rather leading this organization, which is very important activity of such a guest lectures under Science Association, Professor Kakade, the student who is helping all this activity. Everybody is welcome, and rather I should appreciate the joint efforts taken by the team. And finally, my dear student friends, today I am going to talk about electronics in general. And what is this subject? Actually, this is my first time to talk you, which is online. So I am trying for it. Yes, electronic science. Why and how to study electronic science? That is the topic. So see, whenever we study any subject, we should always think that why we are studying this subject. Okay, how to study this subject? What are the necessary things for its study? All these things are to be studied. Remember, we use two words, electronics and electronic science. Whenever we associate the word science with any subject, there are some other dimensions. Science includes many subjects: physics, electronics, chemistry, mathematics, botany, zoology, geology, and so on and so forth. Microbiology. There are so many subjects which are being added to the list. The list is not complete. What we study in science? I will give an example. Newton saw that an apple is falling down the earth. He observed that many people were observing, was he might how it happens. So that why, how, etc., all these questions which trouble our brain and start the process of thinking, that is science. In science, we answer, or rather try to find the answers of all such questions. For that purpose, we propose a theory. For proposing a theory, we make some hypothesis, assumptions, and then have a proper formulation of the theory. During this formulation, we have to use mathematics. Remember, directly or indirectly, mathematics is the basis of all the sciences. So mathematics, we have to work out all these thoughts which come to our mind. That is philosophy. That is to be put up in the form of mathematical laws, etc. That's why we need mathematics. Okay, mathematics is done. Experimentation, whatever we say, whether it is correct or not, that is to be tested by doing some experiments. So experimentation is another aspect. During experimentation, we get some results, some data, observations are there, and those are to be analyzed properly. So for that purpose, we have to use many tools. Statistics is one of the subject, which is very powerful device nowadays. So computations of various types are involved in the analysis of the data. That's why computational matter comes. So in this way, when you talk about study of science, we study theoretical aspect, then we study mathematical aspect, we study computational aspects, experimental aspects, and then finally, for doing the experiments or out of experimental analysis, we develop some instruments. And do we study it only for the sake of study? No, there should be some applications. Whatever we study, whatever things should be useful for the mankind. And that's why we have to think about the applications of the thing which we are studying. So in science, we study these things, don't forget. Theoretical aspects, mathematical aspect, computational aspect, experimental aspect, instrumental aspect, applied aspect, and then finally commercial aspect. Because we have prepared some instruments, we will purchase it at that too at lower price in a very efficient manner, good quality products. And that's why quality control and all these things, in general, commercial aspect we have to account for. So these are the things nowadays we study in science, remember. You will ask the question, many people were asking whether electronics is good or physics is good, whether mathematics is good or, I think there is no point in asking such questions. तुम्ही कधी विचारलंय का हो की गोड चांगलं का आंबट चांगलं, आंबट चांगलं का खारट चांगलं, खारट चांगलं का तिखट चांगलं? असे प्रश्न विचारणं चुकीचं आहे. दोन चवी असतात का नाही त्यांची कधी तुलना होत नाही. Two tests cannot be compared, remember. Similarly, you cannot compare two subjects because every subject has got its importance, it has got its own merit, typical applications, characteristic features, and that's why you cannot compare. But still then, what is your liking? Do you like this subject? That is very important. But still then, remember, electronics has got its own merit. Nowadays, if you see, electronics and telecommunication, they are at the top of the list. Computer programming, that is also there. Mechanical engineering, that is there. So in this way, we can think of various subjects. Electronic science has got its own merit, and that's why it is at the top. So what is there in electronics? So let us see something about the typical or special features of electronic science in today's lecture. Now please remember, if you ask FIBSC student, what is electronics? He will say electronics. Electronics means components, resistors, capacitor, inductor, some circuits, etc. What is electronics? Electronics is the study of all these things. Is he right? Yes, he is right. Because in FIBSC laboratory, study components and various types of circuits. That's why he says that electronics means different types of components and circuits. That is fine. Please remember, the student is perfectly right. Because electronics is the subject which is more learned in the laboratory. Remember what I say, electronics is the subject which is better understood and studied in laboratory. So you have to build up various types of circuits, design them first of all, build, and then test variety of electronic circuits. If you see the question slips in the examination, next practical examination, you will find build, design, build, and test the following circuit. In MSc, all the students, they do it. So this is the thing which you have to note. These three words, design, build, and test variety of electrical circuits. So what is the importance of all these things? Let us see. That is one thing. We will discuss about it in today's lecture. Why should we study electronics? It has got some applications. Now, if you see the applications, so make a list of the application areas of any subject. Every subject has got its application areas. As I told you, no subject is inferior. Electronics, what are the applications? Right from consumer products, optoelectronic devices are there. आपण ज्या वेळेला घरामध्ये काही गोष्टी करतो, आपल्याला दिवा लागतो, पंखा लागतो, सगळ्या टीव्ही लागतो, सगळं लागतं, मोबाईल लागतो, अहो हे सगळ्या गोष्टी आपल्याला लागतात. तेव्हा त्याच्यासाठीचे प्रॉडक्ट काय ते पहिले महत्वाचे आहेत ना. त्यामुळे कमर्शियल प्रॉडक्ट इज व्हेरी इम्पॉर्टंट. देन ऑप्टो इलेक्ट्रॉनिक डिव्हायसेस आर देअर. इन मेडिकल फील्ड ड्युरिंग ऑपरेशन्स एटसेट्रा medical instruments are there. Then military weapons, I should not talk about it much, you are quite aware. Everything automatic, high speed, precise, radar, communication. So these are the applications from military field area. Then automobiles, aerodynamics. These are some of the fields where electronics finds tremendous applications. Satellite communication. आपण चंद्रावर गेलो, मंगळावर गेलो, आता गुरुवरती जायची आपली तयारी आहे. निरनिराळ्या प्रकारचे उपग्रह जे आहेत ते आता आपण तयार करतो आहोत आणि विविध कारणांसाठी, चांगल्या कारणांसाठी आपण त्याचा वापर करतो आहोत. सॅटेलाइट कम्युनिकेशन. मग अशा उपग्रहांशी जर संपर्क करायचा म्हटला तर कसा करायचा? 15 भाषेचं पोस्टकार्ड लिहायचं का? नमस्कार, पत्रास कारण की वगैरे नाही होते, तसं नसतं ते. इलेक्ट्रॉनिक्स कम्युनिकेशन, इथून सिग्नल पाठवायचा, तो तिकडे जायचा, तो तिकडे येणार, परत लगेच त्याची ऍक्शन होणार. म्हणजे इलेक्ट्रॉनिक कम्युनिकेशन याच्यासाठी अँटिना डिझायनिंग. और अँटिना म्हणजे काय? अँटिना डिझाईन कशी करायची? लहान पाहिजे. 2 किलोची अँटिना जर तिकडे बसवली तर ते कसं काय होणार? पेलोड कमी पाहिजे आपल्याला. त्यामुळे कमी वजनाची, जास्तीत जास्त चांगली, खूप फ्रिक्वेन्सीला रिस्पॉन्स देणारी अशा प्रकारची अँटिना आपल्याला पाहिजे. मग असं जर करायचं आहे तर कसं करायचं? त्यासाठीचा रिसर्च इलेक्ट्रॉनिक्स मध्ये होतो आणि म्हणून सॅटेलाइट कम्युनिकेशन इज व्हेरी इम्पॉर्टंट ब्रांच नाउडेज. ऍग्रिकल्चर, आपल्या सगळ्यांना माहिती आहे की शेती हा तर अत्यंत महत्वाचा क्षेत्र आहे की ज्याच्यामध्ये आज खूप रिसर्च चालू आहे. ऍग्रिकल्चर फील्डमध्ये वनस्पतींची मशागत असेल, अनेक प्रकारच्या औषधाची फवारणी, ऑटोमॅटिक, असं सगळ्या अनेक ऍप्लिकेशन्स ऍग्रिकल्चर फील्डमध्ये असतात. स्पीच अनालिसिस, स्पीच सिंथेसिस, these are some of the areas. For example, I am speaking, मी आता बोलतोय, मला लगेच ते छापून पाहिजे पलीकडे, कसं करणार हो? ते सगळं लिहितात, प्रोग्रामिंग करतात, पण ते प्रत्यक्ष एक्झिक्यूट करणार कोण? इलेक्ट्रॉनिक्स. डिजिटल सिग्नल प्रोसेसिंग, डिजिटल इमेज प्रोसेसिंग, या साऱ्या फील्डमध्ये इलेक्ट्रॉनिक्सची ऍप्लिकेशन्स आहेत. रोबोटिक्स, आय थिंक आय शुड नॉट टॉक अबाउट रोबोटिक्स. यंत्रमानव, काय बोलायचं रोबोटिक्स? आता लहान मुलाला सुद्धा माहिती की रोबोटिक्स म्हणजे काय. And lastly, I have inserted numerical computations. You may be having mathematical formulas, theoretical concepts, etc. That is all right. But how to do all the calculations fast and in a very precise manner, online, automatic. So for that purpose, we have to use numerical methods. Numerical method, they're programming. But finally, all the calculations are done by using circuits which use different gates like AND gate, OR gate, XOR gate, etc. in the circuits. We are having two disciplines, remember, analog and digital electronics. Out of them, digital electronics plays an important part in numerical computations. So these are some of the applications. The list is not complete. And that's why we study electronics. So what is electronics? As I told you, if you ask any person what is electronics, he will say electronics means electronic components, circuits. If you ask some other person what is electronics, अरे electronics means बोले बहुत भारी होता है. Electronics means electronic gadgets, entertainment. मी एकदा तुळशीबागेमध्ये गेलो आणि तिथे दुकानदाराला विचारलं की अरे मला जरा थोडंसं एक सुंदर असं भेट वस्तू द्यायची आहे, तर काहीतरी वस्तू द्या, गॅजेट द्या, खेळणं द्या. त्याने मला 2-3 दाखवली. म्हटलं ही नको, मला इलेक्ट्रॉनिक्स वरती बेस्ट अशी काहीतरी पाहिजे. त्याने ती पण दाखवली. म्हटलं हे नको, आवाज येणार असं काहीतरी दाखव जरा, कारण मुलगा लहान आहे, त्याला अट्रॅक्टिव्ह वाटलं पाहिजे. सो ही शोड मी, ते बघा, तिथे बघा. वरती बघितलं तर वरती काय होतं, एक रिंग होती, ती अशी टांगलेली होती, त्या रिंग मध्ये एक पोपट होता. म्हटलं व्हॉट इज दिस, याच्यात कुठे इलेक्ट्रॉनिक्स आहे? तर म्हटलं थांबा साहेब. त्यांनी टाळी वाजवली आणि टाळी वाजवल्याबरोबर तो पक्षी नाचायला लागला आणि तो गाणं सुरू झालं, एक सुंदर गाणं, आणि तो पक्षी नाचतोय. अरे मी म्हणलं काय आहे, आय वॉज व्हेरी मच सरप्राइज्ड. नंतर त्याने पुन्हा टाळी वाजवली, ते बंद झालं. पुन्हा टाळी वाजवली, पुन्हा गाणं सुरू, नाचणं सुरू. Then I understood, oh, there is electronics in it. I immediately paid the amount and purchased that. So see, I was thinking that how it was developed. Then I came to know he used the principle of clap switch. टाळी वाजवल्यानंतर ध्वनी ऊर्जा म्हणजे साऊंड एनर्जी निर्माण होते, त्याच्यावरती जे चालतं सगळं ते त्यांनी वापरले सर्किटमध्ये. अशा प्रकारची कितीतरी गॅजेट. मध्यंतरी दिवाळीमध्ये एकाने एक चांगली केली, पणती असते ना आपली, पणतीमध्ये आपण तेल लावतो, वात लावतो आणि दिवा लावतो. त्याने असं काही आणलं होतं प्रॉडक्ट बाहेर की तुम्ही पाणी ओतायचं आणि एकदम दिवा लागणार. तर तो एलईडी त्यांनी वापरला होता, लाईट एमिटिंग डायोड, आणि आतमध्ये खाली सर्किट होतं, पणती सारखीच पणती. पाणी टाकलं की लगेच दिवा लागायचा. किती ते लोकांना आवडलं, भयंकर आवडलं बघा. पणती आणि तो दिवाच्यात काही फरक नव्हता. म्हणजे इलेक्ट्रॉनिक्सची जे आपण सर्किट्स वगैरे शिकतो त्याचा कसा वापर त्यांनी केला होता युक्तीने आणि पैसे मिळवले. तर हे खूप गमतीशीर गोष्टी असतात. म्हणून इलेक्ट्रॉनिक गॅजेट निर्माण तयार करण्यासाठी आपल्याला सर्किटची माहिती असावी लागते आणि ऍप्लिकेशन कसं करायचं थोडंसं डोकं आपण वापरायचं असतं, आपली कल्पनाशक्ती वापरायची असते. सो दिस इज ऑल व्हॉट इज नीडेड. सो इज इलेक्ट्रॉनिक्स मेन ओनली फॉर डेव्हलपिंग सच गॅजेट्स, एंटरटेनमेंट गॅजेट्स? Yes, it is not the only way, remember. It is not the only reason. Yes, it is electronics, no doubt, but it is not the only electronics. Now, when you enter the laboratory of FIBSc, what you study, different types of components. Identification, first of all. इट इज व्हेरी इम्पॉर्टंट. तुम्हाला जर आईने सांगितलं की बाजारात जा आणि पालकची एक गड्डी घेऊन ये, पालक, तुम्ही गेलात आणि मेथीची गड्डी घेऊन आला. आई म्हणाले काय आणले? आई म्हणले तू आज आहे आणलं. अरे म्हणले बाबा हा पालक नाहीये, ही मेथीची गड्डी आहे, मेथीची भाजी आहे. अरे मला काय माहिती? प्लीज रिमेंबर माय पॉइंट. यू शुड नो की पालकची गड्डी कशी असते, त्याची पानं कशी असतात, काय असतात, वगैरे वगैरे सगळ्या गोष्टी. त्याप्रमाणे in electronics, if you want to develop some circuit, suppose you want to use one resistor, 10 kilo ohm resistor or 1 kilo ohm resistor, you go to the market, Rajiv Electronics वगैरे बरेच काय चांगल्या चांगल्या दुकान आहेत, तिथे तुम्ही गेलात आणि विचारलं मला 1K चा रेजिस्टर पाहिजे. तो म्हणे 1K, व्हॉट इज स्पेसिफिकेशन, स्पेक्स प्लीज, असं तो म्हणेल. स्पेक्स प्लीज म्हणजे काय? तुम्हाला कळलं पाहिजे की स्पेक्स प्लीज मीन्स what are the specifications of the register. मग तो म्हणाल थांबा मी सरांना विचारतो. सरांना फोन लावला, हॅलो सर, ही इज आस्किंग अबाउट स्पेक्स. अरे कार्बन कॉम्पोजिशन रजिस्टर 1K क्वार्टर वॉट. मग त्याला सांगितलं की त्याला कळतं. म्हणजे थोडक्यात काय की 1K 10 कॉम्पोनंट त्याने पुढे ठेवले, 1K which register you want. So I must know the specifications. I want carbon composition register which is 0.5 or 0.25 watt. And for this purpose, rough purpose, if I want highly precise value of 1K only, then I use wire bond resistor, etc. So whenever you are building some circuits, you are using components, and those components, which one to be selected, what is the precision, what are the specifications, those must be known. Similarly, there is another aspect. If you look at the experiments, the first experiment, IV characteristics of a diode, PN diode. Next practical, IV characteristics of a Zener diode, IV characteristics of this so and so. Alright, you will say, what is this? PN diode, Zener diode, Ha diode, To diode, सगळ्यांचे IV characteristics. Apply the voltage, measure the current, and plot the graph. Alright, you will say, what is this? Please remember, you must understand or try to know why they are giving this practical. The practicals are designed in a very nice way and in very nice order. Why we apply voltage and measure the current and plot the graph? From IV characteristics, we come to know how the resistance of the device is changing. Right? If you go to a doctor and say, sir, असं असं होतंय डॉक्टर बरोबर, ते पहिल्यांदा काय करतात? टेम्परेचर बघतायत, पल्स रेट बघतायत, हार्ट रेट बघतायत, झालं. They ask some questions. Why every doctor does it like this? तुम्ही आम्हाला डोकं दुखतंय, ते बाकीचं काय बघताय? Doctor is very perfect member. Because from all these preliminary things, he comes to know about the general health. Similarly, whenever you are given any component, you are studying its IV characteristics. From IV characteristics, you come to know how the resistance of the device is changing, or in which voltage range the resistance is changing much faster, much slower, etc. What is the importance of resistor in electronics? If suppose you are having some resistor, you pass some current I for a time t, then I square RT, that is the electrical energy wasted or heat generated, I square RT. If resistance is higher, heat generated or energy lost will be more. And that's why resistance value is very important. If the resistance is changing during operation, the energy heat generated will change with time. That is one thing. Another thing is that whether current goes like this or like this, that is whether current is positive or negative, I square is always positive. If t you consider time, it is always positive. So I square is positive, t is positive. So I square RT will be positive if R is positive. If the resistance is positive, that is I versus V graph, if it is like this, then the resistance will be positive and component will definitely consume power. But if the graph is like this, I versus V, if the graph is having negative slope, what does it mean? It means that if you increase the voltage, current decreases. If you decrease the voltage, current increases. It means the graph of I versus V has a negative slope. It means the resistance is negative. If the resistance is negative, then I square RT will be negative. What it means? It will not consume power, rather it will supply power, remember. So negative I square RT will be negative if the resistance is negative. It means the power consumed or will be negative. मला 100 रुपये द्यायचेत म्हणल्यानंतर इट इज लॉस टू मी. मग काय करू, मला -100 रुपये द्यायचे. अरे रडतोस काय मग तू, -100 रुपये द्यायचे त्याचा अर्थ तुला मिळणारच कुठून तरी. तसं पॉवर कंझ्युम्ड इज मायनस, याचा अर्थ त्याला पॉवर मिळते. म्हणून इन इलेक्ट्रॉनिक्स इफ द आय वर्सेस व्ही ग्राफ हॅज अ नेगेटिव्ह स्लोप, it will supply power rather than consuming power, and that's why there are some devices which are very important. Resistance is very important, remember. So we study in electronics different IV characteristics, remember. Is it electronics? It is electronics, but it is not only electronics, remember. At a higher level, when we go to TYBSc and MSc, we study very high level circuits which are highly precise, online and offline automatic application purpose instruments, remember. We are studying all such instruments. हार्टचं ऑपरेशन चालू असताना टक 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 आणि असा तो सिग्नल चालू असतो, ते ऑनलाईन सगळं कळतं आपल्याला. अशी इन्स्ट्रुमेंटची मेजरमेंट करणं, त्याची जनरेशन करणं, हे सगळं जे आहे का नाही, हे आपण हाय लेवलला शिकतो. इज इट इलेक्ट्रॉनिक्स? येस, इट इज इलेक्ट्रॉनिक्स. पण म्हणजे सगळं एवढं सगळं म्हणजे इलेक्ट्रॉनिक्स का हो? नाही, इलेक्ट्रॉनिक्स हे काहीतरी वेगळं आहे, लक्षात ठेवा. याच्यापेक्षा आपल्या गोष्ट लक्षात ठेवली पाहिजे. ओके, विच डिव्हायसेस अँड सर्किट यू शुड नो. मला इलेक्ट्रॉनिक्सचा अभ्यास करायचा आहे, मला आता कळलं काय 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 ते. आय मस्ट नो अबाउट ऍक्टिव्ह अँड पॅसिव्ह कॉम्पोनंट्स. वी अप्लाय डिफरंट सोर्सेस, DC source, AC source, etc. We apply ramp voltage, then triangular voltage, square wave voltage, etc. There are different types of signals. I must know something about them and the instruments which are generating all such signals. I must know what are the different types of diodes, then PN diode, Zener diode, etc. I must know transistors. Remember, diode to transistor, it's a very beautiful transition in electronics, remember. Invention of transistor has changed the entire scene of electronics applications. So BJT, bijunction transistor, JFET, junction field effect transistor. Think over these two. JFET means some different principle is being used. Field effect is used in the action. Action is same, but the field effect is used. Similarly, metal oxide semiconductor field effect transistor, MOSFETs. MOSFETs are very important. तुम्ही ट्रान्सफॉर्मर बघितलेला आहे, एक प्रायमरी असते, एक सेकंडरी असते, आणि प्रायमरी टू सेकंडरी वगैरे. Now when you design such circuits at higher level, we use MOSFETs, remember, in the higher level. So this is one thing which you must know. Then I talked about negative resistance region. Which devices have negative resistance? Unijunction transistor, silicon control rectifier, diac, triac, PIN diode, gun diode, impedance, etc. There are various devices. एक मुलगा म्हणाला सर ते चुकलंय, PIN diode हे पिन डायोड म्हणणार, तसं नाही. ते PIN डायोड हे वेगळे डिव्हाइस आहे, त्याचा रेजिस्टन्स निगेटिव्ह असतो. मला जसं कळलं ना, PIN डायोड विसर उचलून खिशात धरून टाकेल, कारण त्याचा रेजिस्टन्स निगेटिव्ह आहे. सो इन इलेक्ट्रॉनिक वी सर्च फॉर and do some research in generating the devices which are negative resistance. Okay, this is all about this, some of the devices. IC is an integrated circuit. Don't forget about this thing. IC has opened new era in the field of electronics. Which circuits? Basic circuits I am talking about. Amplifier. Hello, hello, 1, 2, 3, 4, mic testing. Hello, hello, mic testing. You are familiar with it. Amplifier, oscillators. I want to generate tremendous frequency signals. पुणे आकाशवाणी केंद्र इतक्या हर्ट्झने बोलतो. व्हॉट इज दॅट हर्ट्झ? ऑसिलेटर्स, काही कम्युनिकेशन साठी, काही सॅटेलाइट कम्युनिकेशन, अनेक प्रकारच्या ऍप्लिकेशन साठी आपण ऑसिलेटर्स डेव्हलप. ऑसिलेटर, व्हॉट आर द डिफरंट टाइप्स ऑफ ऑसिलेटर्स? कॉलपिट्स ऑसिलेटर, हार्टले ऑसिलेटर, वाइन ब्रिज ऑसिलेटर, there are different types of oscillators. So oscillator is one of the type of circuit. Then filters. आपण चहा करताना काय करतो, ते दूध वगैरे सगळं टाकतो, साखर वगैरे, चहा वगैरे, आणि नंतर तसंच पितो का? तसं नाही पित. गाळणं वापरतो आणि त्याच्यामधून ते चहा होतून अनवॉन्टेड पार्ट ठेवतो आणि बाकीचा सगळा घेतो. वी नो दिस filter. Similarly, whenever you are talking, suppose you are transmitting the signal, that signal is going in the air and some additional signals they are mixed with it. So the original signal gets corrupted. Can you use it directly? No. We have to eliminate that signal. And that's elimination of the unwanted signal, which is called the filtering. That is done by electronic filters, remember. So noise, an unwanted signal, that is eliminated. There are different types of filters. एकच प्रकारचे फिल्टर वापरतो का आपण? नाही, अनेक प्रकारचे फिल्टर्स असतात. So we are having such electronic filters. What are the different types of filters? It is very big topic, remember. Attenuators are there, the lag network is there. Another thing is that by using electronic circuits, we want to make some, just carry out some mathematical operations. So operational amplifier, which is called as op-amp, IC741, is a very famous IC. For addition, subtraction, differentiation, multiplication, integration, all such mathematical operations are done by using circuits which use op-amp. Study of op-amp is a separate subject, remember. Then don't forget, remember, MUP and MUC. What you are doing? MUP project. What you are doing? MUC project. What is this MUP project and what is this MUC project? Microprocessor and microcontroller. These are the key words in the field of electronic circuits, remember. So these are some of the basic devices. Yes, I have talked about ICs, remember. Don't forget ICs, analog ICs and digital ICs. Another core word is very important, key word. It is sensor. Sensors is the heart of electronics. We want to sense many things. तुम्हाला समजा एखाद्या रूमचं टेम्परेचर कॉन्स्टंट ठेवायचं आहे, तर ते टेम्परेचर कॉन्स्टंट आहे का नाही हे कशावरून कळणार हो? यू हॅव टू सेन्स. किंवा एखाद्या इंडस्ट्रीमध्ये एखादा वायू निर्माण होतो आहे, CO समजा, किंवा SO2 वगैरे, की हॅझार्डस टू हेल्थ. मग असा वायू तयार झालेला कळणार कसा? हाऊ टू सेन्स. त्यासाठी काहीतरी पाहिजे. म्हणून इलेक्ट्रॉनिक सेन्सर्स हा एक प्रकार असतो. इट विल सेन्स. ओके, हवेमध्ये ऑक्सिजन किती आहे, CO2 किती आहे. How will you come to know? So some instrument, some device should sense it. The sensors, pressure sensors, then the velocity sensors, proximity sensors. माझ्यापासून पुढचं व्हेकल किती अंतरावरती आहे, that I want to sense. So the electronic sensors. So here I have shown one slide, remember, so to give some idea. All such information is available. You can see, but don't forget that sensors is the heart of electronics. Here I have shown one slide. Agriculture purpose slide is being the sensors are being used, and this is another thing, very interesting. You know that there is a plant and the roots are there. You want to know about the situation of the roots. Will you dig the farm and just see and what are they? कसं काय तुझं बरं आहे का, कसे आहेत तुमचे मुळं वगैरे, बरं वाटते ना खाता? No, we can't do it like that. Without digging the earth, you are to sense what is the situation of the roots, what they want. So all such agricultural studies below the earth, moisture contents किती आहेत जमिनीमध्ये, we want to test. So for that purpose there are some sensors, and agriculture is very important field, and don't forget that, remember. So this is all about what I wanted to talk in the half part of my lecture. Now I will talk about an important thing, that is analogous electronical quantities. Why to study electrical circuits? Please remember what I am saying. Analogous means similar, sarke. याच्यासारखं ते. Analogous electrical quantities. I will talk about all such things in a very brief manner. Please remember, every system can be finally converted into an equivalent electrical circuits. Every system can be converted finally into an equivalent electrical system or circuit, and then can be studied for its performance in the laboratory. म्हणजे काय मला म्हणायचं की समजा एरोप्लेन चाललेलं आहे, आणि मग एरोप्लेनचं तुम्हाला स्टडी करायचं, तर एरोप्लेन कॅन बी ट्रीटेड एज एन इक्विव्हॅलंट टू इलेक्ट्रिकल सर्किट. एखादी पंप चालू आहे, समजा गिरणी चालू आहे वगैरे, यू वॉन्ट टू स्टडी दॅट कॅन बी ट्रीटेड एज एन इक्विव्हॅलंट टू सर्किट. डोळ्याचं ऑपरेशन चालू आहे, दॅट आय कॅन बी ट्रीटेड एज एन इक्विव्हॅलंट सर्किट, इलेक्ट्रिकल सर्किट, रिमेंबर. आणि मग इलेक्ट्रिकल सर्किट यू कॅन जस्ट कन्सिडर अँड स्टडी इट इन द लॅबोरेटरी. इफ यू इन्क्रीज द व्होल्टेज वॉट विल हॅपन टू द करंट, याचा अर्थ तिकडे फ्युएल रेट वाढला तर असं असं होईल वगैरे वगैरे. So in this way, if you consider any such system which can be finally converted into an electrical circuit, then in electrical circuit you can study in the laboratory, and from those variations you can come to know or predict about what will happen in the given system. That is the importance of this analogous electrical quantity. If you open up any engineering book, remember, you will find the first chapter, analogous physical quantities. तुम्हाला कळेल की ज्याला आपण टेम्परेचर म्हणतो ते म्हणजे पोटेन्शियल झालं होते, इलेक्ट्रिक पोटेन्शियल ज्याला म्हणतात ना ते म्हणजे टेम्परेचर. तुम्हाला कळेल तर हिअर आय गिवन सम एक्झाम्पल. Force means voltage, or voltage means force. Inductance means mass. Then electric current is just like velocity. Electric charge is just like linear displacement. तुम्ही एक ठोकळा घेतला लाकडी आणि त्याला फोर्स लावला, it will move. This is a mechanical system. What is electrical equivalent? So if you know that mass is equivalent to inductance, force is equivalent to voltage, etc., and displacement is just like current, you can convert it into an equivalent electrical circuit and analyze it further, give the answer. So if you are not knowing electronics, or if you are knowing electronics, you can go from electrical to mechanical system, or if you from mechanical to electronics, such conversion can be done very fast. There are many analogies, remember. You can have force means current. So what will be inductance in that system, etc. Please try to find out all such information from the net. Analogous physical quantities, that is the title. How to do or how to obtain such analogies? I have given a very simple example. You know kinetic energy. If a block of mass m is moving with a velocity v, its kinetic energy is 1/2 mv square. Everybody knows that by 10वी पासून शिकतोय तुम्ही 1/2 mv square, where m is the mass and v is the velocity. If you take an inductor, म्हणजे कॉइल असते त्याच्यामधून करंट पास केलं, if you pass some current, then what will happen? There will be magnetic field generated, etc., and there will be a storage of magnetic energy as with the inductor. How much is the magnetic energy? It is given by 1/2 L into I square. L is the inductance and I is the current flowing through it. Right? So these are the two expressions. One is from mechanics, one is from magnetostatics. But please remember, even though these are from different fields, both pertain or both are related to energy. So here we are having kinetic energy, magnetic energy. Expressions are also similar. 1/2 mv square, 1/2 Li square. So from this I can say that mass is equivalent to inductance and velocity is equivalent to current. So I say that m is just like inductance and velocity is just like current. In this way we can get analogies. Please do refer to the net for analogous physical quantities. As an example, I will talk about lever. तुम्हाला माहिती तरफ एखादा मोठा दगड जर उचलायचा असेल ना तर आपण काय करतो, एक टेकू असतो, मोठी पहार घेतो, ती पहार अशी ठेवतो, त्या टेकूवरती ठेवतो, पुढे दगड असतो, असा फोर्स लावला की तिकडे उचलला जातो. We know this lever. Here we are applying some force because of which there is an uplifting of the load. So this force is equivalent to a voltage. Here I have shown in the diagram that there is a voltage V2, right? On my right side, we are having the load which is being shifted, and the part of the lever from Afer to fulcrum, that is equivalent to a resistance R1. Then fulcrum to the load, that arm is equivalent to resistor R. And this conversion of or just transmission of force from one to the other place is indicated by the op-amp. So this mechanical system of a lever can be shown to be equivalent to an electrical circuit which is shown. So the electrical circuit you can show in the laboratory without performing the actual practical with lever, etc. If you consider DC electrical circuit and water level, there is water in the tank, and that water is flowing through the tap and the wheel is being rotated, right? This system that is equivalent to an electrical circuit where the water in the tank is equivalent to a battery and the wheel which is being rotated is equivalent to a bulb and the tap which is just like a switch. So this is analogy. If you consider our respiratory system, फुफ्फुसं वगैरे सगळं. Then on the left hand side, we are having all such respiratory system, and that is equivalent to an electrical circuit, which is shown on the right. Heart, yes, we can. You can see get those diagrams. Equivalent circuit of heart, how heart operates. Eye, how it operates. So, what is the equivalent circuit of an eye? All these things you can get. Please remember, we are talking about IC, integrated circuit, 555, timer mode. If you use IC 555 in a timer mode, that can be used in the heart as a pacemaker, remember. So these are some of the applications. Now we will see something else. Somebody will say, oh sir, can I avoid electrical circuits? I don't want to build up circuit, etc. Can I avoid electrical circuit? The answer is yes, to some extent. An electrical circuit can be expressed in terms of a computer program developed on the basis of a mathematical function, which is called as a transfer function. Remember that concept of transfer function, that is mathematical, right? In an amplifier, what you are doing, you are giving some input, there is circuit, the signal passes through it, the circuit processes, and finally you will get the output. We vary this and we note this. This is what we do. So that entire circuit can be converted into a program. This is input, this is output. So what is the relation between output and input? So output upon input, that is called as a transfer function of the system. And there is a mathematics. Remember, Laplace transform is to be used. Many other things are there. I will not enter into that jungle. I may not come alive of that jungle, and because of time limit also, we cannot talk about such thing. But please remember, output upon input, that is transfer function of the system. And once you know the transfer function, you can develop computer program step by step, all such statements. And that program is to be fed in to the computer. In the figure, what you are getting some input, analog, that is just signal, etc. Computer cannot understand analog signal. It only understands the language of zeros and one. That's why this analog signal is to be converted into zeros and one. That is digital signal. How it is done? First of all, it is chopped and then it is converted, etc. So that is done by an important card which is called as analog to digital conversion, A to D conversion. I think if you look at the diagram, you will find there is a signal, then A to D conversion. That ADC card, that converts analog to digital, and that digital signal in terms of zeros and ones enters the PC. PC accepts all those values as an input and the program is run. Program is run, you will get the output. That output is also still in zeros and ones, that is digital form. That you have to convert into analog. That's why on this side we used to have digital to analog conversion, right? So digital to analog conversion, we need two cards, A to D and D to D. In SYBC or TYBC, you study all these things. So once you convert the digital signal into analog, then you can have display output. You can see on CRO, you can get the printout, etc. So output device which is to be used, that depends on internal volume. But this is the idea. An electrical circuit can be replaced to a computer program, and that can be run on PC. And that's why this technique is called as PC-based instrumentation. In Pune University, many people, they have done Dr. Under Shaligram, Professor A.D. Shaligram, he was guiding about such projects. Now, what are the advances in electronics? What are the advances in electronics? I have talked about few things, right? So you must know about some typical words. समजा आपण गप्पा मारत बसतो ना, अरे इलेक्ट्रॉनिक्स लय भारी असतं बरं का ते, हा त्याच्यामध्ये ते याजमा असतं, तबूक असतं, 2-3 शब्द आपल्याला माहिती पाहिजे. Virtual instrumentation, real instrumentation we have seen, virtual instrumentation. There is no actual instrument, but still then you are doing. Please remember, on PSpice, we are having simulation softwares, correct? Without building the circuit, you can just actually play with the circuit, see what are the effects, etc. This is virtual instrumentation. AI, that is the keyword of 21st century. Artificial intelligence. Circuit is taking its own decision, right? Artificial intelligence. In robot, we are having such use of artificial intelligence. electronic nose, electronic eye, electronic ear. These are some of the things which will actually attract you to electronics. Remember, we must know what are these things. Or you are quite fortunate students because you are 21st century students. You are having access to the internet, and on internet, different types of books are available, images are available, then abstract research paper, everything you can get. Once you know the keywords, then you can enter those and just see what are the references. In this way, I think you have to study electronics. Please don't forget, right from identification of components, IV characteristic, building different types of circuits, testing them, designing, etc. All this. You should be the architect of electronics, remember, right? You should know each and everything. That is part of it. You will say mathematics. Yes, mathematics is okay, but how much? For electronics, we must know. You may not be able to solve the problem completely, but you must be able to, you should know how to solve the problem. Because or solving the problems on mathematics, there are online softwares. But if you don't know what is Laplace transform, etc., then you can't use those softwares. That's why you must be knowing something about mathematics, basic concept, etc. Skillfulness, skill is to be developed. Experiments which you are doing in the laboratory, those develop some particular skills, and you should be very much aware about all such things. That is electronics. Remember. Finally, I am coming to the end of my lecture. आपण चंद्रावर गेलो, मंगळावर गेलो, आता गुरुवरती गेलो. मग गुरु तर किती लांब आहे. मग अशा ठिकाणी जर आपल्याला कम्युनिकेशन करायचं असेल तर किती फ्रिक्वेन्सी लागेल. आता मंगळाच्या वेळेला आपण गिगाहर्ट्झ 10⁻10 हर्ट्झ इथपर्यंत गेलो. आता गुरुवरती जर जायचं असेल ना तर आपल्याला 10⁻12 हर्ट्झ म्हणजे 13 हर्ट्झ एवढी फ्रिक्वेन्सी द्यावी लागेल. एवढी फ्रिक्वेन्सी कशी देणार, ती कशी जनरेट करायची, कसा ऑसिलेटर जनरेट करायचा, हे एकट्या इलेक्ट्रॉनिक्सच्या लोकांचं काम नाही. याच्यासाठी फिजिक्सची माणसं लागतील, मटेरियल सायन्सची लागतील, मॅथमॅटिक्स लागतील, कॉम्प्युटर सायन्सचे लोक लागतील, क्वांटम मेकॅनिक्स आपल्याला जरा थोडासा अवघड वाटणारा विषय असेल, केमिस्ट्री लोक लागतील, सगळे लोक याच्यासाठी काम करत आहेत. मल्टिपल बॅरियर रेझोनंट टर्निंग डायोड नावाचा एक मोठा प्रोजेक्ट आहे की ज्याच्यामुळे 10⁻12 हर्ट्झ असे आपण जनरेट करू शकतो. आणि 13 हर्ट्झ फ्रिक्वेन्सी जनरेट केली की आपण चाललो गुरुकडे. गुरुकडे काय, कुठल्याही ग्रहाकडे. यापुढे यशाकडे अखंड जप घ्यायची ही आपली इच्छा असली पाहिजे, ती पूर्ण हो. त्यासाठी आपण इलेक्ट्रॉनिक्सचा अभ्यास करावा. मी शेवटी SP कॉलेजचे माननीय प्राचार्य, उपप्राचार्य, सायन्स असोसिएशनचे काकडे सर, विभागाचे विभाग प्रमुख, त्यानंतर महामुनी सर आणि हे आपल्याला जे असिस्टंट करतात विद्यार्थी, या सर्वांचे मी अत्यंत आभार मानतो. आणि आपण सर्वांनी माझं हे पहिलंच लेक्चर ऐकून घेतलं त्याच्याबद्दल आपण सर्वांना धन्यवाद देतो आणि रजा घेतो. धन्यवाद.
Thank you, Khedkar sir. It was really a nice talk and great vision for electronics for our students. म्हणजे असं आहे की बरेचदा आपल्या आजूबाजूलाच इलेक्ट्रॉनिक्सची प्रिन्सिपल्स असतात, पण ती आपल्याला लक्षात येत नाहीत. ती तुम्ही लक्षात आणून दिलेली आहेत या प्रकारात. बऱ्याचशा साध्या साध्या गोष्टींमध्ये जी प्रिन्सिपल्स आहेत तीच इथे इलेक्ट्रॉनिक्स मध्ये वापरलेली आहे. ते तुम्ही चांगल्या पद्धतीने लक्षात आणून दिलं. त्याच प्रकारे पुढे ऍडव्हान्स सगळ्याच ऍप्लिकेशन्स मध्ये इलेक्ट्रॉनिक्स हे लागतच आहे आणि त्याचा अभ्यास पण करायलाच हवा आहे. ही नीड पण तुम्ही चांगल्या प्रकारे समजावून सांगितली. थँक्यू व्हेरी मच.
थँक्यू. धन्यवाद सर्वांचे.
Thank you, sir. Thank you for your enthusiastic talk. Actually, you not only given an importance of an electronics, but also you touched to the part of physics, and we are too much happy for that. Now, I would like to request Prashant Mahamuni from Department of Electronics. Please, sir, ask the questions for the today.
Thank you, sir. Sir, first question is, what is difference between electronics and electrical?
Yeah, in electronics and electrical, the main difference is due to the concept of holes. Remember, concept of holes, because in electrical circuits we are having current. in the beginning, electric current means the flow of electrons only. That was the concept. When the concept of holes was developed, electric current means current due to motion of electrons as well as holes, and that changed the entire concept in electronics. So that is the main difference.
Okay.
Yes, sir. You can ask the next question.
Okay.
Yeah.
Yes. How much mathematics is important in electronics?
I think I have answered this question partially. You should
Yes.
know about electronics. Huh? You should know about Laplace transform. You should know what differential equation, etc. Matrices, all these things. You may not be able to solve the problem, remember, completely, but you should know how to solve it. दिल्लीला कसं जायचं हे माहिती पाहिजे. दिल्लीला नाही गेलं तरी चालेल. कारण काय इलेक्ट्रॉनिक्स मध्ये सर्किट डिझायनिंग आहे. डिझायनिंग साठीची फॉर्म्युला त्याची कोणत्या किमती काढाव्या लागतात. त्या कशा काढायच्या हो? एकदा असं की डिफरन्स इक्वेशन सोडवा. डिफरन्स इक्वेशन माहिती नाही तर काय सोडवणार? दॅट्स वाय यू नीड नॉट गो इन टू द डेप्थ ऑफ मॅथमॅटिक्स. मॅथमॅटिक्स ज्याला करायचं ना त्याला कम्प्लीट माहिती पाहिजे. थिअरी माहिती पाहिजे, प्रूफ माहिती पाहिजे, त्यातले सगळे प्रोज अँड कॉन्स, सगळे त्यातले ड्रॉबॅक्स माहिती पाहिजेत. कुठं चुकू शकतो माणूस किंवा कुठं चुकीचं आहे हे ओळखण्याची क्षमता मॅथमॅटिक्सच्या विद्यार्थ्यांमध्ये पाहिजे. फिजिक्सच्या विद्यार्थ्यांमध्ये त्याला त्याचे ऍप्लिकेशन जमलं पाहिजे. लक्षात ठेवा, मॅथमॅटिक्स आणि फिजिक्स हे अगदी एकमेकांच्या जवळचे सब्जेक्ट. ऍप्लिकेशन समीकरण वाय इज इक्वल टू mx प्लस सी, दॅट इज मॅथमॅटिक्स. फिजिक्सचा माणूस म्हणेल अरे याचा अर्थ असा आहे की ते गॅसवरती एक पातेले ठेवले, त्याच्यामध्ये पाणी आहे आणि ते पाणी तापते, जर टेम्परेचर कसं बदलेलं तो लगेच फिजिक्सचा माणूस म्हणणार वाय इक्वल टू mx प्लस सी, याचा अर्थ हे पाणी तापतंय. दॅट इज अन ऍप्लिकेशन. म्हणजे फिजिक्सच्या माणसाला मॅथमॅटिक्स मध्ये ऍप्लिकेशन दिसतं, व्यवहारात उपयोग दिसतो. लक्षात ठेवा. इलेक्ट्रॉनिक्स माणूस काय करणार, ठीक आहे पाणी तापतंय त्याचं टेम्परेचर मोजणार कसं म्हटल्यानंतर मेजरमेंट झाली, सेन्सर्स झाले, ते करण्यासाठी इलेक्ट्रॉनिक सर्किट. इलेक्ट्रॉनिक सर्किट चांगलं कसं बांधायचं हे इलेक्ट्रॉनिक्सच्या माणसाला आलं पाहिजे. आता हे बांधताना त्याला जर समजा थोडंसं काही मदत लागली गणिताची वगैरे तर तेवढी पुष्कळ झाली. ती फार मॅथमॅटिक्स लागतं असं मुळीच नाही, असं माझं व्यक्तिशः मत आहे. म्हणजे जरी माझा मॅथमॅटिक्स आवडीचा विषय असला तरी माझं अत्यंत प्रामाणिक मत आहे इलेक्ट्रॉनिक्सच्या विद्यार्थ्याला स्टडी करताना मॅथमॅटिक्सला घाबरून जायचं कारण नाही. हा समजलं पाहिजे एवढं माझं. आणि मला वाटतं 12वी पर्यंत गणित जे आहे ते पुष्कळ होतं त्याला, किंवा नसलं गणित माहिती तरी ते जुजबी माहिती करून घेता येतं. मला सांगा तुम्ही कसं कळलं सारं पास झालं, त्याच्यावर थिअरम नाही आलं तरी चालेल. जॉमेट्री हा ते माहिती पास झालं. मोठमोठाले प्रॉब्लेम सांगितले तिथे, तर एवढं जुजबी माहिती असेल मला वाटतं पुरेसं आहे. फार जाऊ नये इलेक्ट्रॉनिक्सच्या मुलांनी गणिताला, पण गणिताचं महत्वही त्यांनी दूर करू नये, म्हणजे दुर्लक्ष करू नये असं माझं मत आहे.
Okay, sir. Thank you. Next question is, how much software is important or programming is important for the electronic students?
प्रोग्रामिंग वगैरे हा जो भाग आहे की नाही हा थोडासा जरा याचा आहे, म्हणजे कॉम्पिटिशन मधला आहे. फिल्टर जरी माहिती नसेल त्याला तरी मुलगा लो पास फिल्टरचा प्रोग्राम लिहू शकतो, की त्याला फिल्टर जरी माहिती नसेल की ठीक आहे असा आहे ना, हा सिक्वेन्स आहे, दिस इज अ प्रोग्राम. त्यामुळे प्रोग्रामिंग हा वेगळा भाग झाला. परंतु प्रोग्रामिंग करणाऱ्या माणसाला जर फिल्टर्स म्हणजे काय माहिती असेल तर तो लिहिलेला प्रोग्राम बरोबर आहे का चुकीचा आहे, किंवा लवकरात लवकर कसा करायचा हे तो माणूस अतिशय स्किलफुली करू शकतो. मी तुम्हाला एक उदाहरण देतो. एक्स स्क्वेअर मायनस वाय स्क्वेअर इज इक्वल टू सो अँड सो आणि एक्स स्क्वेअर प्लस वाय स्क्वेअर इक्वल टू सो अँड सो. व्हॉट आर द व्हॅल्यूज ऑफ एक्स अँड वाय? तुम्ही असं कराल की डायरेक्ट दोघांची बेरीज कराल, एक्स स्क्वेअर मायनस वाय स्क्वेअर प्लस एक्स स्क्वेअर प्लस मायनस वाय स्क्वेअर. दोघांची बेरीज 2x स्क्वेअर इक्वल टू सो अँड सो, देअरफॉर एक्स इक्वल टू दिस अँड देअरफॉर वाय इक्वल टू दिस. साधं दिसतं ना ते, पण कॉम्प्युटरचे लोक सांगतील चुकीची आहे. तुम्ही बघा काढून पुस्तक बालकृष्ण त्याचं बालगुरुस्वामीचं पुस्तक, त्याला प्रॉब्लेम दिलेला आहे. का बरं प्रॉब्लेम दिला मी हा बघितलं नाही म्हणून तुम्हाला सांगतो की अशा या पद्धतीने वाटतं, पण प्रोग्रामिंगची माणसं म्हणतात की नाही असं नाही करायचं, असं केलं ना तुमचं वाटतंय प्रोग्राम तुमचा 2 स्टेटमेंट मध्ये होतं ना, माझा 10 मध्ये होईल, पण एक्झिक्युशन टाइम ऑफ द प्रोग्राम जो आहे ना तो बघायला लागतो नेहमी. स्टेटमेंटची 10 झाली, 15 झाली, 20 झाली तरी चालेल, परंतु एक्झिक्युशन टाइम काय आहे, किती वेळात उत्तर देतो कॉम्प्युटर, हा एक भाग आहे. गणिताचा भाग जो आहे की नाही तो असा आहे की मी तुम्हाला सांगतो सायमल्टेनियस इक्वेशन्स जे असतात की नाही, म्हणजे 3y+7y वगैरे 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 3 इक्वेशन व्हॉट आर द व्हॅल्यूज ऑफ x and y. मी 7x ऐवजी 6.99x केलं, थोडं एक दोन थोडं फरकाने बदलले, तीच इक्वेशन उत्तर काय दिलं एक्स वाय झेडची, लोक म्हणतील काय 6.99 काय सारखेच आहेत, तसं नाहीये ते. मी एकदा मुलाला एका परीक्षेमध्ये प्रश्न दिला, हुशार मुलगा होता भयंकर, तो गोंधळून गेला, माझं काहीतरी चुकलंय, म्हटलं तुझं काही चुकलेलं नाहीये, सोडायचे की नाही याची किंमत खूप कमी येते आणि त्यामुळे तुझी उत्तर चुकत आहे. म्हणजे 7x+4y करून जे उत्तर येत असेल ना ते आणि 6.99x+ घेतलेलं उत्तर अतिशय वेगळी येतात, बंगाट येतात. असं कसं, म्हणून मी त्याला सांगितलं की शास्त्रीची जी पुस्तके न्यूमरिकल मेथडचे ते बघ, त्याच्यात इल कंडिशन मॅट्रायसिस आजारी मॅट्रायसिस असं बघ, मग तुला कळेल. आणि म्हणून इलेक्ट्रॉनिक्स मध्ये व्होल्टेज किती आहे, ते 7 आहे का 6.99 आहे. तुम्ही म्हणाल त्याला काय चालते सगळं नाही, काही सर्किट अतिशय सेन्सिटिव्ह असतात, त्यामुळे हाय प्रिसाइज व्होल्टेजेस मेंटेन करणं हे त्या ऑपरेटरचं कर्तव्य असतं. काही उदाहरणं त्याची ऍप्लिकेशन्स आहेत त्याची. आणि म्हणून इलेक्ट्रॉनिक्स जरी कॉम्प्युटर प्रोग्रामिंग जरी माहिती असलं तरी त्याला थोडंसं माहिती पाहिजे, कारण तो काही उत्तर काढलं होते असं नसतं ते त्याचं. त्यामुळे मला वाटतं थोडं नॉलेज हे पाहिजे. आणि लक्षात ठेवा इलेक्ट्रॉनिक्स मध्ये आपण जेव्हा झिरो काढतो की नाही, झिरो म्हणजे काय, झिरो म्हणजे मशीन जो असतो ना, मशीन डिझायनर, तो मशीन कॉन्स्टंट असतो, तो मशीन कॉन्स्टंट वरून झिरो ठरतो. त्यामुळे काही गोष्टींची उत्तरं या सॉफ्टवेअर त्या सॉफ्टवेअरने काढली, त्या सॉफ्टवेअरने काढली तर वेगवेगळी येतात. त्यांचं मशीन असतं नाही तो वेगळं असतो.
Yes, sir. Please have next question.
Hello.
Yes, sir.
Am I audible?
Yes.
Next question is, sir, how to remember or memorize circuit diagrams since students find it difficult?
Circuit diagrams, yes, it is all right. First of all, we should know the building blocks first. Block diagram, that is very important concept in electronic circuits. Block diagram. So in a block, for example, op-amp circuit, amplifier you should know. Amplifier is connected to this stage, that is connected to that stage, etc. So basic circuits must be known first, and then how to couple that practice. काही मुलं काय करतात की आकृती काढायला लागले की मध्येच कुठेतरी ओपॅम्प काढतात, मग काहीतरी करतात, मग ते असं करायचं तसं करायचं, असं अजिबात नाहीये. सर्किट दिल्यानंतर तुम्ही ते बरोबर त्यातले ब्लॉक्स कुठले कुठले आहेत ते काढायचा प्रयत्न केला पाहिजे. त्यामुळं आपण जे FY ला SY ला मुलांना शिकवतो की नाही बेसिक सर्किट, ती पुढे कपल कशी करायची हे शिकवलं पाहिजे. सायकल आहे, सायकल समजा, तर सायकल शिकवताना किंवा एखादं मशीन शिकवताना तुम्ही त्याची जर पार्ट त्या मुलाला कळले तर मग त्याला कळेल की अरे एकदम स्पोक नाही बसवायचा, एकदम ती चेन नाही बसवायची, त्याचा अर्थाचं प्रोसिजर आहे, कारण त्याला माहिती असतं की चेनचा उपयोग काय, चेन शेवटी येते सगळ्यात. तर त्याप्रमाणे सर्किट इलेक्ट्रॉनिक सर्किट लक्षात ठेवताना त्याचे पार्ट्स माहिती. मी एकदा अगदी सुरुवातीला ज्या वेळेला मी इलेक्ट्रॉनिक्सचा माणूस आहे, इलेक्ट्रॉनिक्स मध्ये ज्या वेळेला आलो त्यावेळेला ते IC 555 शिकवायची पाळी आली. मी म्हणाले IC 555 म्हणजे काय त्याचं, त्यावेळेला ते सर्किट बिर्किट होतं इंटरनल. मग मी ते सगळं बघितलं, मला आश्चर्य वाटलं. मग मी नंतर लक्षात आला या पार्टचं फंक्शन काय, या पार्टचं फंक्शन काय, 1/3 VCC 2/3 VCC काय म्हणणार. मग ते सगळं करून मी असं डायग्राम मला स्वतः तयार केला. आणि मग मला असं लक्षात आलं की
Hello, sir.
Yeah, sir. Go ahead. I think
Okay.
there is a network problem.
Okay. Sir, last question is, what are the job opportunities in electronics in India?
मला वाटतं सरांनाच इंटरनेट प्रॉब्लेम असावा.
Yeah, I think yes, he is coming back. No problem.
Okay. Wait. Hello, sir.
Sir, actually, Mahamani sir asked you the question regarding the job opportunities, and on the similar line, I want to continue that. Now, the skill development is a new part of education.
Skill development
is a new part of education. So, is the electronics propose some kind of courses or some kind of opportunities in that way?
Yeah, electronic science actually it has tremendous opportunities. We have to search for it. First of all, electronics and computer they should go hand in hand because a little bit mathematics and computer programming that is needed for designing electronic circuits. We can get jobs in the IT industry because they are absorbing now electronics people because electronics people is having more skill, right? They are very much skillful. They know little bit physics also, mathematics also, programming also. So we have to start developing this. Another aspect which is very important is power during electronics. We are playing with power devices. Koina project, for example, there they need the persons who are expert in power electronics. There are some industries which need atomization, remember, automatic control systems. So these industries, you have to search for such industries. And another thing is that, lastly, I will tell that you have to develop the product of your own, right? Product of your own that will be sold in the market. For that purpose, innovative ideas are to be used. Innovative circuits. एक विद्यार्थी होता आडोचा तर मार्क कमी पडायचे त्याला 56-58% पडायचे परंतु त्यांनी बघितलं की टू व्हीलरचा हा एक प्रॉब्लेम आहे आणि म्हणून त्याने एक सर्किट बांधलं आणि आम्हाला दाखवलं आंबे सर वगैरे आम्ही होतो तो म्हणलं सर बघा मी हे सर्किट केलेलं आहे त्यांनी ते बघितलं सरांना खूप आवडलं एन एम कुलकर्णी होते त्यांनी पण बघितलं ते म्हणले की आपण असं करूया त्या सायन्स पार्क त्यावेळी जगदाळे सर डॉक्टर जगदाळे होते त्यांनी त्याला पाठवलं जगदाळे खूप ते अप्रिशिएट झालं की या टीवायचा मुलगा एवढं जर करतोय आणि म्हणून त्यांनी ते शाळीग्राम सरांकडे पाठवले विद्यापीठात ते म्हणले करत केलं शेवटी त्यांनी सर्किट डेव्हलप केलं आणि मग ते म्हणले काय करू कंपनीत जा म्हणले तू एखाद्या कंपनीकडे गेला कंपनी म्हणते की अरे वा त्यांचे एक्सपर्ट होते सगळे इलेक्ट्रॉनिक्सचे ते म्हणले तुम्ही विकशील का मला हे यू सेल इट टू अस विकशील का म्हटल्यानंतर केवढ्याला विकशील तो मुलगा टिवायचा होता तो म्हणला की अरे बापरे मी म्हणतो उद्या सांगतो तो आला डिपार्टमेंटला तो म्हणला सर किती सांगू 5,000 सांगू का 5,000 अरे म्हणलं 5,000 काय सांगतो ते त्याला आयडिया नव्हती हो पैशाची अजिबात त्याला फक्त एवढंच माहिती की कौतुकाचे 2 शब्द पाहिजे होते केवढ्याला विकशील तू आम्हाला हे सर्किट आणि मग त्याच्या लक्षात आलं हे पेटंट असा तो विद्यार्थी होता यार 5,000 रुपये काय विकतो 5,000 रुपये म्हणजे काही नाही तो मुलगा लक्षात ठेवा तो पुढे खूप मोठा झाला त्याने ते सर्किट डेव्हलप केलं आणि मला एके वर्षी एका इंजिनिअरिंग कॉलेजमधून फोन आला की सर अमुक अमुक विद्यार्थी तुमचं नाव सांगतोय तर तुमचं विद्यार्थी आहे का म्हणलं हो म्हटलं का हो ते म्हणे की मी हे पेटंट घेण्यासाठी तो माझ्याकडे आला आहे का इलेक्ट्रॉनिक सर्किटचं हो म्हटलं खरंच त्या मुलांनी पेटंट घेतलं लक्षात ठेवा साध्या गोष्टींमधून मुलं किती पुढे मोठे होऊ शकतात याचं हे मोठं उदाहरण आहे तर अशा प्रकारचं इलेक्ट्रॉनिक्सच्या गोष्टी स्वतः जर डेव्हलप केला तर प्रॉडक्ट्स विल बी सोल्ड इन द मार्केट आणि अशी मला वाटतं थोडीशी आपण हे केली पाहिजे नोकरी हा एक भाग झाला इलेक्ट्रॉनिक इंडस्ट्री असेल तुमचं कंट्रोल सिस्टीम्स असतील वगैरे वगैरे या सगळ्या गोष्टी ठीक आहे त्याची ऑपॉर्च्युनिटी शोधली पाहिजे आणि अशा पुष्कळ कंपन्यांची माहिती हल्ली नेटवरती उपलब्ध होते आणि फायनली रिसर्च तुम्ही जर रिसर्च मध्ये पडला ना की तुम्हाला काहीतरी नवीन सुचतं आणि ज्यावेळी तुम्ही काहीतरी नवीन शोधून काढता त्यावेळी त्याची किंमत व्हायला वेळ लागतो परंतु एकदा किंमत झाली की लोकांना आणि तुम्हाला देखील पुष्कळ त्याच्यामधून फायदा होऊ शकतो.
Can you highlight the future technologies since we are moving the generations in progress of science? Electronics plays a significant role. We changed from transistor to the ICs, and we have seen the number of equipments nowadays which are there. They are very sophisticated equipments, we can say, and user friendly. So now we are moving ahead. So what kind of changes you are expecting in a research in electronic point of view?
See, now electronics research will not be pertaining to non-living beings at all only. Now they will be dealing with the research of living and non-living together, right? Every body continues to remain in its original state. That was a statement of Newton's law. Now everybody remembers. So if you just reduce the gap between the two words of Newton's first law, everybody will continue to move. So how two plants, how two living organizations will work, how the cell structure, when they are combined, they will get developed. All these things should be studied automatically. Atomization, high speed, highly precise computations, online as well as offline. That is the research, especially in the field of biology, microbiology, and all such things. Remember, that is the challenging task. Now this corona period is there, so people are very much dark on its study. So how to study all these things? It's a very difficult task. And in electronics, people, they are making an important role. They are not using only diodes and transistors, etc. Some high-level applications, concepts, they are being used in the analysis of such tremendous data, and that is electronics. So satellite communication is one of the branch where electronics has tremendous scope. I told you about generation of terahertz frequency, 10⁻12 hertz. There we need electronics, but not our normal electronics. We have to take help of physics people, mathematics people, etc. Right? So this is one thing which you should know. Virtual instrumentation I have talked about, and there are many, especially in medical field, then the military field, satellite communication. These are some of the things. Artificial intelligence I talked about, electronic nodes. These are some of the things. So I think the student should use internet and the search for such advanced topics in surgery, especially the instruments which are being used. Those are electronic instruments, and now photon is being replaced by electronic. So that photonics is there, which is the physics part, but still then the circuitry part is related with electronics. Quantum computing is there. There are many other things. So physics, electronics, they will go hand in hand. Remember nowadays. आता physics वेगळं, chemistry वेगळं, botany वेगळं असं नाही करू शकत आता. We have to go together, think about all these subjects together. So that is 21st century challenge. So I think we have to search for such applications.
So in recent generation, multidisciplinary education will play a significant role, as the national education policy also highlight the same thing. Now I would like to request Professor Sanjeevani Vipat ma'am, if any question, ma'am, you can ask the question. It's okay, ma'am. If you don't have questions now, ma'am is actually, you are unmuted, ma'am. You are muted. Please unmute yourself.
Finally, I would like to comment my own comment.
Yes.
प्रश्न माझ्या पद्धतीने तिला उत्तर दिली. यातलं जे योग्य असेल तेच घ्यावं, अयोग्य असेल ते सोडून द्यावं, खेडकर सरांचं असं म्हणावं. कारण बिग बॉस जे शुकाचार्य आहेत त्यांचं एक वचन भागवतामध्ये, श्रीमद भागवतामध्ये आहे, ते असं आहे, युक्तियुक्तम वचो ग्राह्यम, युक्तियुक्तम वचो ग्राह्यम बालादपि शुकादपि, युक्तायुक्तम वचस त्याज्यम वृद्धादपि शुकादपि. If somebody is logically consistent, may it come from the mouth of a parrot or a little child, it should be accepted. And if somebody is talking logically inconsistent, should be rejected. May it come from the mouth of an old man or शुकाचार्य. असं प्रत्यक्ष शुकाचार्य म्हणतात की मी जरी सांगितलं आणि ते तर्क विसंगत असतं ते ऍक्सेप्ट करू नका, तर्क सुसंगत गोष्टी. तर मला वाटतं सायन्सचा स्टडी करताना मुलांनी हे केलं पाहिजे. खेडकर सर म्हणतात म्हणून ते बरोबर मुलीच नाही.
It's not an objectionable thing. Whatever the things you told us, all are the scientific one. So we don't have any doubt about it. Ma'am, you have any questions or we have to go ahead?
नाही, we can go ahead. आणि सायन्स हा सगळा सब्जेक्टच मुळी तर्कावरच आधारलेला आहे. त्याच्यामुळे
हो.
तर्काचं सगळं विश्लेषण झाल्याशिवाय किंवा जे काय मनात वाटतं ते प्रत्यक्ष प्रूव्ह झाल्याशिवाय कुठलीच गोष्ट सिद्ध
That is
होत
right.
Right.
Exactly.
So,
हे
sir,
शास्त्रात
very enthusiastic talk. Actually, you have compared the mechanical systems with the electronic circuits, with the different examples like the lever, how it is working as like operational amplifier circuits, or we can say heart, how it works like IC 555, or how we can say the whole force as an voltage or mass as an inductance. So, thanks for your talk. Now, officially, I would like to request Prashant Mahamuni, sir, please give the vote of thanks for the today's talk.
Thank you, Kakade sir. It is always great pleasure to hear Khedkar sir, and I remember from his student days that he always says some verses or shloks in Sanskrit, and he has very good command over Sanskrit also. Now I am here to propose vote of thanks. It is my privilege to have been asked to propose a vote of thanks on this occasion. I, on behalf of SP Mandali's SP College Pune Science Association, SP College Pune, and Department of Electronics SP College Pune, first of all extend my most sincere thanks to our eminent speaker, Professor J.V. Khedkar sir, who spared time from his busy schedule to be with us. Secondly, I thank to our principal, Dr. Savita Datar Madam, HOD Professor Sanjeevani Kulkarni Madam, and Vice Principal Professor Dhananjay Divte sir for their support and encouragement in making this event successful. I would also like to thank in charge of Science Association, Dr. Sandeep Kakade sir, for his efforts in planning and organizing the talk. I am also thankful to all members of Science Association, colleagues, and all those who are directly or indirectly associated in organizing this event and making it successful. Finally, I am thankful to all the audiences who attended today's session and benefited from it. Once again, thank you to all for being with us. It has been a great pleasure. Thank you very much.
Thank you.
Thank you. Thank you, Mahamuni, sir, and thank you to all. And here I will this conclude that today's session is over. I would like to request all participants please join for the next session on tomorrow at the same time. Tomorrow will be the last session of Science Talks organized by Science Association. So thank you. Good night. Thank you.
Thank you, sir.